All right, so the next one, this is number 7. The mass of Mars is given to us in kilograms. The radius is given to us in kilometers. Calculate the density. Okay, so once again, we just did a problem like this for Mercury. The density is the mass divided by the volume. Of course, the mass has to be in grams. So let's convert that right away. So 6.4 is a decimal. Times 10 to the 23rd kilograms. So in 1 kilogram, there are 10 to the third grams. Right, so the kilograms cancel, and so this becomes 6.4 times 10. 23 plus 3, it would be 26 times 10 to the 26 grams. All right, there we go. So that's our mass in grams. The volume's a bit more tricky, so we have to convert the radius to centimeters. All right, so we got 3389.5 kilometers, and we do the exact same thing. 1 kilometer is 10 to the third meters. 1 meter is 10 to the second centimeters. So, you just take this number, multiply by 10 to the fifth, right? 10 to the third times 10 to the second is 10 to the fifth. So it becomes 3389.5 times 10 to the fifth centimeters. All right, so that's the number we're going to use in our volume equation, right? So the volume is 4 pi over 3. So times the radius to the third power. And this will be the radius that we use, right? Because the radius has to be in centimeters. All right, so this is very similar to the problem we just did. We just have different numbers, okay? All right, so let's clear that. All right, so here we go. I'll put that right there. All right, good. All right, so I'm going to do the volume part first. So I'm going to take this number. So 3389.5 times 10 to the fifth. 10 to the fifth. All right, and then I cube that, raised to the third, and then so here, this is what it is, raised to the third power, and then times 4 pi, times 4 times pi, divided by 3. All right, so that's that's this very, very large volume in cubic centimeters. I'm going to store that just so I can use it a little bit later. All right, so then I put this number in 6.4 times 10 to the 26th. All right, so 6.4 times 10 to the 26th divided by the number that I just stored, and that's going. So that is going to be the density of Mars. All right, so when we do this, it says round to one place past the decimal, so it would be 3.9. Right, so the density of Mars. All right, so the density of Mars turns out to be 3.9. And of course, it's grams per centimeter cubed. But they already asked us to do it in grams per centimeter cubed, so we're just looking for this numerical value. All right, very nice. All right, let's look at the next problem. All right, I figured you need some practice doing these, and we might as well do them with all the do the same calculation. You're going to see the same thing with all of the all the terrestrial planets. Anyhow, now for Venus, all right? So we have the mass of Venus, all right? And so we're going to calculate the density, right? So the mass is 4.87 times 10 to the 24th. It's, of course, kilograms. And so we got to do this. 1 kilogram. Kilogram is 10 to the third grams. The kilograms cancel. And so 10 to the 24th times 10, times 10 to the third is 10 to the 27th, right? So this becomes 4.87 times 10 to the 27th grams. All right, so and then the radius is given to us again in kilograms. So 6051.8. It's going to be times 10 to the fifth. All right, so let's just prove that. So kilometers. Oops, sorry, not kilograms. I think I said kilograms a moment ago. So kilometers, 10 to the third is 1 meter. Kilometers cancel, and then you say 10 to the second, 100 centimeters in 1 meter. All right, the meters cancel. All right, so this becomes 6051.8 times 10 to the fifth centimeters. All right, so there we go. And calculate the volume, which is always 4 times pi. As long as it's spherical, 4 pi divided by 3 times the radius to the third power. And then, of course, the density is going to be the mass in grams divided by the volume in cubic centimeters. All right, so let's figure out the volume using this number here. Where's my mouse? Oh, there it is. So this is it, and let's get our calculator. All right, so that was, of course, the density of Mars. Now we're going to do the density of Venus, which is going to be closer to the Earth. Remember, the Earth is 5.5. All right, so here we go. So 6051.8. All right, 6051.8 times 10 to the fifth, exp to the fifth. All right, now I have to raise that to the third power. To the third equals, you don't have to hit equals right there, but anyhow, times 4 times pi divided by 3 equals. All right, so that's the volume. That's going to go here in the denominator. So I'm going to store that once again. Stored. All right, so that's stored. And then, here, let me just verify it. So yeah, same number. Okay, good. All right, so, and then what I'm going to do is I'm going to take the mass, which is 4.87. All right, so 4.87 times 10 to the 27th, right? Because 3 plus 4 to the 27th divided by, and so I'm going to divide that by what my volume, which was I put in memory, so that's this volume. All right, so this is going to be a number. It's going to be greater than Mars's density, but less than that of the Earth. And there it is. So let's see. What do we do? We're going to round one place past the decimal. So it says, so it's 5.2, right? So the next digit is 4, so you don't round up. So 5.2. 5.2 is the grams per centimeter cubed. And just as a reminder, the density of liquid water, fresh water that is, has a density of 1 gram per cubic centimeter. So often we'll compare the density to the density of liquid water. All right. Yeah, let's do the next problem. All right, so this is problem number 9. If you're keeping track, for our sample problems for test number 2. All right, so the mass of Mercury is 3.3 times 10 to the 23rd kilograms, and its radius is 2,439.7 kilometers. Calculate the surface gravity in meters per second squared. Round to one place to pass the decimal. Just as a reminder, the surface gravity of the Earth is 9.8 meters per second squared. All right. So anyhow, the one thing that we do have to do a conversion. This has to be the radius has to be in meters. So that's easy. So that's R is 2439.7 kilometers, and of course there are 10 to the third meters in 1 kilometer. All right. So the kilometers cancel. And so, that's all right. So the surface gravity. All right. So I called that A sub G. That's supposed to be an A. A sub G. Surface gravity is big G times the mass of the world, of the whatever world you're talking about, divided by the radius squared. All right. So let's put the numbers in. So it's 6.67 times 10 to the minus 11th. That's big G. And then the mass is already given to us. The mass of Mercury is 3.3 times 10 to the 23rd kilograms. And that's correct. All right. So it's got to be in kilograms divided by, all right. So it's going to be 2439, 0.7 E3. But remember, of course that's meters, and then you square that. All right, so there are actually units of big G, and that makes everything work out so that the acceleration due to gravity, or the surface gravity is what it's called, is going to be in meters per second squared, just like it is on Earth. All right, so let's get our calculator and we'll do this calculation real quick because I'm running out of time. All right, so here, let's clear this, get it a little closer. All right, so 6.67 times 10 to the minus 11th times the mass of Mercury, 3.3 times 10 to the 23rd divided by, so remember, I want to divide by this number, but then I got to square it. So it's 2439.7 E to the third, but then of course I've got to square that. All right, and then so that's going to equal. All right, so the surface gravity on Mercury would be 3.4, right? 3.4 compared to the Earth, right? So well, I mean, if we compare, it's much smaller. So 3.4, and of course it's meters per second squared. Remember, for the Earth, just keep that in mind. For the Earth, it's 9.8, right? So just it's always good to compare, the surface gravity. If you ever hear people talking about like an airplane pulls so many G's, this is 1 G, right? This is the acceleration due to gravity, right? So this is much smaller for the planet Mercury, because of course Mercury is much smaller. It's the smallest of the planets, and it doesn't have very much mass, right? And as I mentioned before, there are moons bigger than Mercury.